Welcome back to our trigonometry series. Today we are up to section 1.5 where we will be looking at reciprocal trigonometric functions. In our previous lessons we've gone over the three main trigonometric functions: cosine, sine, and tangent. Using the right triangle here as a reference, we know that the cosine is adjacent over hypotenuse, or A over C. Sine of theta would be opposite over hypotenuse, or B over C. And the tangent would be the opposite over the adjacent, or B over A. We've also looked at this right triangle on the unit circle. Here, cosine of theta would be x over r, the radius of the circle. Sine would be y over r, and tangent would be y over x. And if we know x and y, we can find the radius using good old Pythagoras. So let's start with our three main trigonometric functions. Our next task would be to find the reciprocal of each function. Now think back to your algebra days. What is the reciprocal? Well, in the case of a fraction, it's just that fraction flipped upside down. So for cosine theta, where we have x over r, its reciprocal would be r over x. We've just flipped the two terms of the fraction. Likewise, the reciprocal of sine would be r over y, and the reciprocal of tangent would be x over y. Each of these functions has a unique name. The reciprocal of cosine is secant, or SEC. The reciprocal of sine is cosecant, or CSC. The reciprocal of tangent is cotangent, or COT. Now you might notice that the cosine goes to secant and sine goes to cosecant. That seems like a mistake, but it's not. It's just the way math is, and I'm sorry about that. It's just one of those weird things that you have to memorize. Let's take a look at this example. We have rotated about the xy axis at an angle theta and ended up at a point 3, negative 4. Now let's find all 6 trigonometric functions. But to do that, we need x, y, and r. Well, we've already been given x and y. That's pretty easy. X is 3. And y is negative 4. Good old Pythagoras can help us find r. If we square x and square y, and then take the square root of that sum, we'll end up with the radius. In this case, it's 5. So we've rewritten our main 3 trigonometric functions. Cosine is x over r, sine is y over r, and tangent is y over x. So we can just substitute the numbers that we've already found. What about the reciprocal functions? The secant would be r over x. We've flipped cosine. So that's 5 over 3. Cosecant would be r over y, which would be 5 over negative 4. And for cotangent, it would be x over y, or 3 over negative 4. Let's jump over the whiteboard and do some examples. Okay, we're going to start by drawing our xy axis. Something like this. And we've got our x and our y. And maybe some arrows. Now we're going to rotate counterclockwise like we normally do and have something that goes here. And we're going to make ourselves a nice right triangle like this. And we're going to say that from here to here is 6. From here to here is 8. And we're going to find all 6 of the trigonometric functions, with this being our angle. So let's just write them out. We'll go over here. We got cosine theta, sine theta, and tangent theta equals, equals, equals. So to do that, we need x, y, and r. Let's see. We've got x, y, and r. Boop, 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 boop. So we're talking about this point here. What is its x value? Well, from the origin, we've gone over 6. So x, in this case, is 6. And we've gone up 8. So this point is 6, 8. What about the radius? Well, we don't have that. But we have a right triangle, so good old Pythagoras, right? So we know that r squared equals x squared plus y squared. Or that r is equal to the square root of that same sum. Still on the screen? Still on the screen. So what's x squared? X is 6. Well, that's 36 plus y squared. 8 squared is 64. And we have just enough room down here. The square root of that, it'd be the square root of 100. Well, that's a nice easy number. Well, it's a square root that actually equals plus or minus 10, because negative 10 squared is 100. But we're talking about lengths and distances here. So the distance being negative doesn't make a whole lot of sense. But we know this would be 10. So that's 10. This is 10. So what is cosine? Cosine would be the angle here, the adjacent over the hypotenuse. So 6 over 10. And we could simplify this to 3/5 if we wanted to, but we'll keep them in the numbers that we have here. Sine would be the opposite over the hypotenuse, 8 over 10. And tangent would be opposite over adjacent, 8 over 6. Whoops, I missed this. We'll just rewrite it here as 6 over 10, and same thing as 3 over 5. Should probably know where my screen ends up here. What about the reciprocals of these? Well, cosine, the reciprocal of cosine is secant. So secant of theta is going to be the reciprocal of this, 10 over 6. What about sine? The reciprocal of sine is cosecant. So the reciprocal will be 10 over 8. And finally, cotangent is a reciprocal of theta. Would be the reciprocal of this value, 6 over 8. Right. Let's clean this off and do a few more examples. Let's just say we have the tangent of theta is equal to -4. What is the cotangent of theta? Well, it would be the reciprocal of this, but this isn't a fraction. So it's time to be a little sneaky. We need to think of -4 as equal to -4 over 1. So this is still -4, but now it's a fraction. So the cotangent of theta would be equal to -1/4. And likewise, let's say we have the sine of theta is equal to 1/2. What is the cosecant of theta equal to? Again, we're taking the reciprocal of this number. So this would be equal to 2 over 1. But we could just rewrite this as 2. And that's it for today. It's a pretty short section. We'll see you next time.